Hi, my name is Mariana Alvarez, and my topic for this research is, in the state of Iowa, has there been an increase or decrease of infant mortality from the year 1990 and 2004? During the years, medicine has had enormous breakthroughs in a variety of health issues around the world, all thanks to medical advancements in technology. We like to believe that things that were prevalent in the past are no longer prevalent or are less prevalent in modern society. For example, an average person may believe that sudden infant deaths are less common now than what they were in 1990 or the 1800s. During this era, health conditions of our ancestors were such that 43% of infants didn't even make it to their 5th birthday. So the purpose of this research is to find out if infant mortality is the same as it was in 1990 in 2004, or has it increased or decreased? The first step is to determine the null alternative hypothesis. It's important to correctly state each hypothesis because they will determine what you are trying to prove with the given data. For example, like we said before, one could reason that infant deaths in 1990 were much larger in 2004 due to these fewer medical advancements. The goal is to prove true the alternative hypothesis and disprove the null hypothesis based on the appropriate hypothesis testing procedures. So here we have stated that mu1 represents 1990 and mu2 represents 2004. So our null hypothesis will be that mu1 equals mu2. That is, that there's no difference in infant deaths in each year. The alternative hypothesis would be mu1 is greater than mu2. In other words, it means that infant deaths in 1990 are greater than infant deaths in 2004. The data for this research was obtained from the Houghton-Mifflin datasets under birth rate and death rate. The actual data was retrieved from County and City Data Book, the 12th edition of the U.S. Department of Commerce. The data is paired by counties in Iowa. So, in order to classify the data, a spreadsheet of 2 separate years was computed. In one column, you have the death rates in 1990, and in the other column you have the death rates in 2004. The population total of all the counties in Iowa was 99, representing the 99 counties. In order to observe the data and compare each year to one another, we also did a bar graph. That's the bar graph. So the hypothesis testing procedure. Because the appropriate hypothesis testing procedure for this data set is a t-test, we first have to do a simple random sample of all the 99 counties in Iowa. The step-by-step to perform a simple random sample on a T183 is to select the math key on your calculator, then select PRB, select option 5, which be rand intervals. Your step 4 is to enter your lowest number to begin the sample, that is 1. Enter the total population size. In this case, I have 99 because those are the 99 counties, and the sample size that you want to obtain. So here's a step-by-step, step 1, step 2 through step 4 on the calculator. And this is the overall result. You would get, you would just compare all the data that the numbers that the calculator gave you to your initial spreadsheet in Excel and just plug those numbers in. The following step is to obtain a sample standard deviation. The standard deviation is denoted as S of X, and it's a measure of the spread of scores within the data. Since we have a sample of the entire population, which is a simple random sample of 30 counties computed from the entire population, we could, from this, estimate the population standard deviation from a sample of standard deviation. The step to compose or compute a sample standard deviation on your calculator is all listed here, step 1 through 7. You would just select data key, select edit. You would enter all your information from each column on list 1 and list 2. Then go back and select stat calc, option 1 var stats. Enter second L1 for data under list 1 and second L2 for data under list 2. Using this same 1 var stats, you will also obtain the mean or X bar and your total number of samples, n equals 30. So this is just the step-by-step in the calculator. Same. The end result will give you a mean for 1990 is x bar 4.07 with a standard deviation of 11.18. And the mean for 2004 would be x bar 3.166 with a standard deviation of 7.28. Since each year has the same amount of number of counties, we will denote the sample size as n equals 30 for both 1990 and 2004. The hypothesis testing procedure is going to be a t-test. So we're going to compute a two-sample t-test to find out the difference between the population means when the standard deviations are unknown and samples are drawn independently from one another. The formula for the two-sample t-test is given here, but you can also perform it on your T183 calculator with following the steps listed here below. Here are the step-by-steps in the calculator. You want to make sure that you select your appropriate alternative hypothesis in the calculator, because if you don't, it's going to give you the wrong results. Then you select not pooled because you want individual results and calculate. The end product is going to be a t-value of 0.3711, your p-value of 0.3560, and that is going to be compared to your level of significance 0.005. P-values evaluate how well the sample data supports the argument that the null hypothesis is true. It measures how compatible the data is with the null hypothesis. High p-values indicate that the data correlates true with the null hypothesis, and that low p-values indicate that the hypothesis is unlikely to be true, the null hypothesis. A low p-value suggests that the sample provides sufficient evidence that you can reject the null hypothesis for the entire population. Next, we have to compute a confidence interval using a two-sample t-interval. The formula for this is listed here. The confidence levels are percentages that estimate the population parameter falls between a specified range. In other words, a confidence level of 95%, which is what we're using, means that we would expect 95% of the interval estimates to include the population parameter. In order to obtain a two-sample t-interval, a t-star is necessary. In order to obtain a t-star, you must first find the degrees of freedom, and then the degrees of freedom for this formula would be degrees of freedom n minus 1. N minus 1 would be 30 minus 1, giving you a degree of freedom of 29. The table C, a distribution of critical values in the back of the book that we've used for the semester, says that with a degree of freedom of 29 and a 95% confidence interval, you will find a value of 2.045. That is your t-star. Here's a chart from the back of the book. That is a step-by-step to perform then your two-sample t confidence interval. You want to select 0.95 as your 95% confidence interval, not pooled, and it will give you a range of negative 3.989 to 5.7968. So, the conclusion for this is that we have to accept the null hypothesis. Our p-value was 0.3560, which is significantly higher than alpha, which was 0.05. So in other words, we have to conclude that there's no statistical chance or evidence that infant deaths in the years 1990 and 2004 were different.